Yeah, Miss Baji, yeah, very good morning. I can hear you, yeah.
Yeah. Thank you very much. Thank you.
Madam has also joined, huh? Madam has
Yeah,
joined.
Madam also has joined. Yeah.
Yeah.
Thank you very much. Thank you all for joining us. It's my great pleasure to welcome you all to this exciting invited track on HPC, AI, and quantum computing at Supercomputing Asia SCA 2025. At the outset, first of all, I would like to extend my thanks to the steering committee to give us this opportunity to conduct this invited track. And in fact, they were very excited and happy to invite us. They said that they want to get the version of HPC, AI, quantum, and hybrid computing advancements in India that we are having. So, thanks to the steering committee. In today's session, we have planned the session in such a way that, first of all, we are going to have the version from the Ministry of Electronics and IT, who is spearheading the missions like National Supercomputing Mission, National Quantum Mission, as well as India AI Mission. So we'll get the first-hand understanding as well as the vision from the Ministry of Electronics and IT, represented by Srimati Sunita Verma, Madam. She is Scientist G as well as Group Coordinator. She is already there online. Can you project it here? Yeah. And then we have a session on talking about India's HPC ecosystem and then indigenous development, and followed by the other sessions.
Somebody is on live mode.
And then we have a session on talking about India's HPC ecosystem and then indigenous development, and followed by the other sessions.
Yes. Yeah, somebody is on.
It is repeating.
Yeah, we can stop sharing.
Yeah, stop sharing already.
Yes.
Okay, I'll mute my side first. Yeah. Okay. Yeah, stop sharing.
Is it because
Okay, finally.
Yes.
Okay, so window shift. Is there?
but when you are speaking, it is a delayed voice again. Right?
Yeah.
So this understands.
Is that? Speak.
Hello, can you hear me?
Yes.
I think they can hear.
Yes, yes.
I suggest is we'll stop it streaming.
It's not streaming.
Yeah.
Share it to
Thank you, sir. So we'll directly move on to our slides of our talk on the system software, or rather introduction to the HPC of what we have achieved with our NSM machine and how we are going ahead with our system software and applications on a whole. So So today's presentation, I would be covering the top 500 machines listed from India, then the NSM infrastructure and its reachability, the system software ecosystem currently what we have supported through both open source as well as what are the tools what we have developed. Then we talk about the Pinaka Studio, the revamped ecosystem, which supports both domain-based and unified programming models. And then we close out with the HPC applications and the achievements what we have worked on with. So starting with, we basically have currently the deployed machines, what we talk of, are the machines which are actually running with a single purpose applications. We have 6 such machines on the top 500 listed. So the first machine from India is Airavat, which has a peak of 13 petaflops and an Armax of 8.5 petaflops. This is primarily used for AI applications and research. Then second machine, actually, it's called as Arca, and there are 2 variants of it. The Arca, which is a CPU-based computation, which gives a R peak of 7.4 petaflops, and Arca AI/ML, which gives a peak of 3.7 petaflops and an Rmax of 2.7 petaflops. Basically, both these machines are used for weather forecasting, and with the GPU-based and the AI/ML-based version of it is with Arca AI/ML, and the CPU-based traditional modeling is run through Arca. Then we have the Mihir, which is again the primary machine or the deployed machine for weather forecasting, which works with 2.81 petaflops and an Rmax of 2.57 petaflops. Then we have Arunika, which is being used at 7.4 which has an R peak of 7.4 petaflops and 5.94 petaflops. Again, the primary main usage is for the weather research. So, and the last machine what we have on the top 500 listed is Pratyush. This is for climate modeling and forecasting. So this has an R peak of 4 petaflops and 3.76 petaflops. So if you're going to total up, together, we have around 38.5 petaflops of compute power listed on the top 500 list from top500.org. And if you observe, most of our deployed machines are working for the either weather forecasting or the climate monitoring or something related to climate and weather. And we have one machine, the Airavat, which is basically focusing on the AI applications and the R&D. So these are the deployed machines. And there was a question on the deployed machines. Yes, the deployed machines are different from the NSM Supercomputing Mission based systems, what we are working out with. They are the R&D machines, which are not listed here. But these are the deployed machines which work with a well-versed applications which are quite well matured enough to run their models and can be used on a daily basis for our weather and climate in India. Then we'll talk about the National Supercomputing Mission. The objective has been, as all of my seniors mentioned, it's about the capacity and capability building. So it started with the objective of boosting the computational needs for both academia, research, MSME, or startups. And the second part of it was building the national capacity using indigenous machines and totally moving towards self-reliance. And this particular mission, National Supercomputing Mission, what we call as NSM short, is funded by Department of Science and Technology, DST, and Ministry of Electronics and Information Technology. Together funds the mission NSM, and the implementing agencies for this is C-DAC and IISc. So what we have currently with the NSM machine, we have deployed 33 systems at 24 different locations in India, which is giving 32 petaflops. This is away from the 38 petaflops what we talked in our, which is listed in the top 500. Okay, these are more of the research and public research kind of building the applications for to be the exascale ready applications. Then the total capacity, what we are expecting by end of year, we intend to push it up to 66 petaflops with right away 20 PF machine, single machine coming up in C-DAC Bangalore, and the other smaller machines to support R&D in the other locations to be put up. So together we'll have a R&D kind of an ecosystem being supported with 66 petaflops of the machine by end of year. And when we look at NSM, we can put these machines into three categories, basically. The public research, the research and development machines, and then the human or HRD development machines. So under HRD, we have 5 machines which are called as Paramvidya. They give around 261 teraflops, which are being used for all the HR activities. Then we have the research and development activities, the test beds, what we require for both applications, software, and rest of the R&D work, for which we use around 1 PF of the machine. We're using 8 machines. And we have 20 machines which are used for public research, which overall currently computes to 30 PF. And if we look at how is the organization of it, we have 96% of these machines which are publicly accessible to all the agencies, all the organizations which intend to do research and develop the applications for HPC-AI. And we have 3%, which is a testbed kind of an environment from where they can move on to the public research systems. And then they have 1% of the machines which we start with for the HR development or for the students and professors to start out with parallel programming and HPC. So it's a gradual progression where you start with the 1% of the machine. Then once you are done, you have a research problem, you can move on to the test bed. And once you are comfortable with the testbed kind of machines, we push you onto the public research machines, which are almost a 96%. That's a 30 petaflop machine available, which is around in the 24 locations. So moving on to what we have achieved currently, we have been able to get around 10,800 plus HPC users across 200 institutes across the country. Before, one of the major objectives of NSM, right, reachability. So this has been achieved with 10,800. Currently, we have 10,800 plus HPC users across 200 institutes. We have supported 1,000 plus PhD students with their research, and they have come out with 1,500 plus publications. We have trained around 23,000 people for in HPC. We have around 105 plus lakhs of HPC jobs which have been executed in this 30 petaflop machines, which are there across the 24 locations. So you can call it as around 1 million jobs. And we have supported, or currently we are supporting around 20 plus startups or MSMEs, what we say, which are using our systems currently. We have a steady 85% utilization of the clusters among all the 33 systems. We have a steady 85% utilization. And now when we look at it, the ROI, as Sir was mentioning, we do the billing system. So we get something like 415 crores in Indian rupees worth of compute power, which has been provided to the nation. So again, if you want to convert it into US dollars, I think it comes up to somewhere around 47 million. So this is the kind of compute power what we have provided to the nation for the public research. So moving on to the software ecosystem. So if you look at till now, I have been showing the different systems what we have had during the various slides, 3 or 4 slides, what the NSM machine supports. So these are again some of the other 6 machines what we have. So not only the infrastructure or the server ecosystem or the software ecosystem matters a lot, right? So this is a software ecosystem what we are supporting and we are working with. And mainly they can be divided into the operating systems, middleware applications and management, and HPC programming tools. We do support a lot of open source kind of tools, and we optimize them according to the requirement of those systems. So the machine, like if we are looking at the operating systems, we have different drivers. Like if they're GPU systems, NVIDIA based, then we have CUDA and the network and storage drivers, OFED. And we have the CentOS, and currently we are supporting Alma Linux. And at the middleware, we support Ganglia, some other C-DAC tools, Nagios, Slurm for accounting, XCAT, and Lustre kind of a file system. Then moving on to the programming languages, we support the Intel MPI, NBA Pitch, OpenMPI, PGAS based on the requirement. So all the softwares are supported along with Intel One API, the GNU toolkit, the scientific libraries, Python libraries, math libraries, ML and DL frameworks, along with the container technology also. So we even support the visualization tools and the performance monitoring using HPC, IOR, and HPCC. So other than this, though we supported the whole open source stack, there are a lot of missing links. So those were the tools what we concentrated on developing and to provide to our NSM users. That forms the LO side or part of the C-DAC tools or components, which I'll be explaining in detail a bit about them. So we start with C-Chakshu. This is a multi-cluster monitoring platform. This is a live dashboard. If you look at it, a single page would give you the complete current aspects of the utilization of all the systems. Here, if you look at this diagram right now, you can see there are around 8 systems and their utilizations which are available for monitoring, and which is this particular web URL is available to everyone, from the management to the PMO to everyone. So an instant access is available and a transparent system is maintained through this. Then we monitor the node, infrastructure, jobs, users, and that listing is available here. We do the analysis based on this particular statistics. What we have the job accounting and billing, based on which we are able to say the compute power what is being used. Then to give a better, easier access in case of any system goes down. The systems are huge. You do not know which rack, which system. So we do provide the 3D rack view, which allows them to actually, if there is a problem in a particular machine, the machine turns red on this web URL. So they know which rack, which system to go and get it right. Then the ticketing system is managed, because of which the management becomes easier. Then we have Parade. So I was mentioning about it. This is a parallel development environment. Usually, traditionally, HPC users have been command line users. But when we see the new crop or the new set of students who are coming in, they do not like the command line. So that is where an IDE becomes compulsory. They are very well versed with Visual Studio, that kind of an IDE world they come in. And HPC didn't have this currently when we started, or even now when we look at it. So that's where we developed this IDE. This is a parallel development environment, which has features of a simple IDE, but is submitted on a HPC and runs HPC jobs. So that's the reason we say this is a IDE for HPC. And we support in a single project multiple paradigms. This is one of its kinds because of that, where we can support MPI, OpenMP, CUDA, OpenACC, and SQL in a single project. It provides an automatic compilation based on the tools and compilers available on the cluster. So it can do an automatic compilation. And for the fine-tuning, you have some make files which would be available here, which are editable for the users to continue further. Then we do an assisted job submission, and it provides adding even custom compilers. Sometimes it happens so that your applications require custom compilers, which are not available on the cluster. So you can add them through this provision is given for adding these compilers, libraries, and tools. And this can be maintained through the version control system for your applications, and support for all the development tools like your debuggers, profilers, and converters are available on this platform. Next, we move on to the CAPC. This is the C-DAC automatic parallelizing compiler, where we automatically convert the sequential programs to equivalent parallel programs. That is, we convert a C or C++ or Fortran kind of a program into OpenMP-based program, OpenMP with C or C++ or Fortran, or with OpenCL, with OpenMP 4.5, that's a GPU version, and the OpenACC. And currently we are working on MPI plus X kind of an automatic parallelization. It doesn't require, usually what you find is you require hints from the users, the kind of converters, but this is an automatic parallelizer. It doesn't require any user hints. It tries to convert to multiple parallel paradigms using even just a web interface, where you put the sequential code and hit one of the codes what you want and you'll get it. And the output is human readable and not a binary. Okay. And more than anything, how does it work? It's not that just it looks at a for loop and it'll do a parallelization. That's not profitable, right? So profitability is looked at it, and based on the profitability of whether converting into a parallelism or a parallel program, if it works, that's when this particular tool will convert that serial code or parts of the serial code into parallel code. So profitability of and is estimated, and based on that, parallelization is taken up. Then we have CHAP. So we call all these the user usability tools, whether it's IDE or the converter or the CHAP profiler. These are something what's useful for the users. So CHAP C-DAC HPC application profiler, it provides insights into the application performance behavior at the cluster level, trying to give the complete application performance summary. If you look at it, the application and its architecture is given, the characterization of the application is shown here, and the potential speed up what you can attain, and the execution summary is provided, and then the configuration summary. So you can do an hotspot identification immediately using it, and you can change or do the further fine-tuning. Let's say if we go stepwise, we usually use an IDE for loading the program. We use the CAPC tool to first convert a serial code to the parallel code. And then further, you can use this profiler to get a better performance and identify the hotspot. But further on, it is left to the users to fine-tune their code. It's their code, right? So the first level of automatic parallelization is taken care. But further on, to get a better parallelization, they can use this CHAP as a profiler, and they can recognize the hotspot, and they can go further on for attaining the better performance. Then we have a power HPC power server utility. This is something which helps our infrastructure, where it's not like we always have all the nodes are up and running and they all are useful. So it goes on in order to save the power. It works on a sleep mode. If it's not being used, it will put into a sleep mode. And when there's a new job and requirement of the compute power, it is we call it as waking up of the node is done, so that the jobs can be submitted there. To allow this to happen, we have integrated with the Slurm middleware, so that as soon as the job is submitted, and in case the current CPUs which are up are not enough, then the sleeping nodes would be woken up and would be used. Since it's integrated with the Slurm scheduler, it makes it easy. And at the same time, it saves the power for the HPC infrastructure. Then at the end of it, we find there are lots of tools and the single interface is missing. That's where the dashboard came in. We have provided something which works across different handles, right from your mobile to a tab to your big monitors. You can use this app or application, and you can do a job submission. This is more of a user portal or a dashboard where they can do an advanced file management. They get their particular accounting and reporting. It's a single sign-on, and then you can move on to any cluster. Then it allows you to do a Siri kind of or interactive job submissions. Just by voice submissions, it can submit your jobs. And it helps with remote visualization. And we use like your functional, how do you submit? You submit it through some Slurm scripts, right? So instead, we have provided integration with MATLAB's job submission. This is more a query and a text kind of a job submission saying, I want to run this particular job, so and so, on some n number of CPUs. So based on that particular query, the whole Slurm script or the whole backend process is taken care, and you can submit the job. And how does it help, or where it would help, especially if you're using your phones or your tabs? This kind of an interface helps a lot in submitting jobs to the HPC. So this is the dashboard, and internally all the tools what we mentioned, whether it's Parade, CAPC or CHAP, they're made available through this dashboard. Then moving on further, so these are the systems and softwares what we worked on. But currently, what is the scenario is we have developed our own Param Rudra, right? Based on the NSM systems, where we use the first version of Param Rudra. Currently, we have 3 installations of it. They use the Intel CPUs and the NVIDIA GPUs. But the whole server is designed by C-DAC, and the system is up on 3 particular locations, latest 3 locations in India. And similarly, we have variants of AMD, where we have the AMD CPUs and the AMD GPUs. AMD CPUs, it uses the Genoa variant of the CPUs, and the MI300X is the AMD GPU. So this is the second kind of a machine or a variant what's coming out in May. And then we do have a processor called as OHM. This is ARM-based. The design is taken from ARM, and we have built the chip, and the whole server would be built based on this OHM processor, what we call. And that will go along with any of the GPUs. So this is the third variant what we have of Rudra, which will be coming. Currently, this is the version what we have, but there are other versions also which are coming up. So this has led us, other than this, now we have, it's not just the GPUs, right? We are even talking of accelerators for AI. So you have the APU, IPU, RDU. I guess in the last 3-4 days, you've come across all the processing units, whether it's an APU, IPU, RDPU, TPU, NPU, or any kind of custom accelerators, right? So there's a whole lot of it. So where does that lead to? Too many architectures, too many vendors, but you're stuck with their particular language, their particular APIs. So every time you need to use a new architecture, you're forced to port the application. A same application, instead of using it directly, you have to first port them, get the performance, and then you can start using on the new architecture. And it's the same continuous process which keeps happening. And you cannot turn a blind eye on a infrastructure which is going to do well, right? You have to adapt, and your applications have to port to it. So this is where we found one more point where we could address and solve the problem. So we started with building something called as Paras ecosystem. The vision of this is simple, that we need to have the hardware agnostic application programming model, where we have the vision as code once and execute on all architectures. For this is the ecosystem what we have in mind, and we have started working towards it. And the goal has been to completely support the ecosystem with unified programming model. And at the same time, the application developers must feel that it's easy to use, and at the same time, they're able to gain performance with this unified programming model across the architectures. So for this, we went ahead with developing a compiler based on the SICL 2020 specifications. So this gives us a unified programming model with the agnostic approach. So we started using the SICL 2020 specification, and we have developed a compiler on it. So this compiler currently what's being developed, it supports the CPUs of x86, both Intel and AMD, and ARM, as well as the power system. And on the GPU side, it supports the NVIDIA and AMD. And we have tested these across the different variants of CPUs and GPUs also. If you look at it, CPUs have been tested across the variants of Intel, like Skylake, Cascade Lake, Sapphire Rapids. Then for AMD, we have tested it against the Genoa CPU processors. We have tested it against NVIDIA Grace, Ampere Ultra, then Fujitsu's A64FX, and IBM Power 10. And for the GPUs, we have tested it against the NVIDIA variants of Tesla V100, A100, and the Hopper H100 and H200. And for AMD, we have tested it across MI300 and MI210. So along with the compiler, we've started the version of supporting it with the debugger and profiler. Currently, this supports the GDP debugger for the CPUs, and the GPUs are under work. Then we use the Tau profiler for both CPUs and the NVIDIA GPUs. And we are working around with the actual developers. As Sir said, you can't develop these things in silo, right? So we actually develop with the work along with the Tau developers to get the support for the AMD GPUs using SQL. And is it only for the NSM machines? No, this was something what we started because applications are everywhere, and Indian users, that might be even beyond the NSM also. So that's where we have made it available on a GitHub repo where they can download and they can use it. And we are open for collaboration for supporting any new infrastructure or any kind of tools what you find very useful or supporting your libraries. We're open for collaboration for these things. So moving ahead with this, so we start with the Pinaka Studio, what we call, with the new developments of the infrastructure. So that is where we have the different systems which are there, whether it's the CPUs, GPUs, AI accelerators, or let's just call them as the XPUs, right? The X can be anything, the C, the G, the AI, right? So for all these systems, we need to have a particular system software or the software stack which can be addressed. together. So that's the reason we went with the name Pinaka Studio, which means a single arrow which can hit multiple architectures at the same time, or rather which can address all the architectures. So the name Pinaka, it is an Indian name. And the next level is the base system software, which supports the basic server softwares. And for the clusters, we support it with these n number of tools and the softwares for it. And then we have the application programming software. These are basically domain-based. Like if you look at it, you have tools, utilities, domain libraries. Each domain of application will have their own set of tools and domain libraries, right? Or their even an ID or their workflows are different. So here the application programming software would be provided based on the domain based. And we are intending to, or rather currently we support the CPUs of Intel, ARM, AMD, and to an extent of the RISC-V also through this. And for the GPUs, the NVIDIA and AMD, along with their own softwares, the open source is added, and including the C-DAC's customized software. So it's a 3 variants which are available for you in a single platform. So moving on to the applications, we have talked about the hardware, we have talked about the software. So what are the applications, what NSM has been able to raise to the, which is ready for exascale, and what are its achievements, what we have been able to do through NSM. So majorly, I'll just cover the 5 disciplines. There are many applications in different disciplines, but currently we would be focusing on today. Let's look into just the life sciences, climate modeling, flood forecasting, oil and gas exploration, material and computational chemistry. Starting with the bioinformatics or the life science, what we say, we have developed under NSM a platform called as NPGDD, that is the NSM platform for genomics and drug discovery. 2 separate clusters, dedicated clusters or R&D clusters were enabled for it. And a whole pipeline was created and worked around. And if you look at it, it's not just C-DAC, which is part of it. You have multiple organizations who have been working along with them, where for discovering the new drugs and to enable the pharmaceutical industries, right from a target identification to the validation, leading to the discovery and optimization, to preclinical tests and the clinical trials. And this we call it as a drug discovery pipeline, which has been enabled on this pipeline. Similarly, we have a genomics pipeline, which is enabled through sequencing, read alignment, then the sequence assembly and the variant calling of it. And this allows us to do the early disease detection and provide the personalized health care. So 2 pipelines have been established. And using these pipelines, these are the applications or the actual problems what we have been able to solve. Right from the small drug molecule optimization to working on the sickle cell anemia, working on the Alzheimer's disease, then on the tuberculosis, drug repurposing for COVID-19 was done. These clusters were dedicatedly used during that time for the drug repurposing. Then computational Ayurveda study for COVID-19. It turned out to be Ayurveda does have its own property of solving or giving a resistance for COVID-19 kind of a disease. So that's when the computational Ayurveda study started. Then they work on, or the application was the biomarkers for cancer, then the population genomics, then liver toxicity studies, or you have the Ayurvedic and the RNA technologies and the Ayurveda-based repurposing. So these are all the applications which have been addressed through the 2 pipelines, what was set up for the life sciences. And these are not only C-DAC, or the pipeline was set up along with the collaboration, and these applications are real-time applications from the agencies, different agencies. Yes, sir, just 2 minutes, I'm done. Then along with it, obviously with the pipeline, you have to support it with different tools, right? So these are the tools which have come out during the NSM, like Vivida, or the big data management solutions for genomic data called Gamut, or you have the binding affinity prediction of a protein ligand servers, or the GoKit, or the fast protein ligand binding free energy prediction. So umpteen number of tools have also been developed which are exascale ready to be used. And obviously these all are being developed with the different collaborators. I think I've been told, okay, I'll just take another 2 minutes. Then the second application is the urban modeling. where we have developed urban modeling, trying to work with the weather plus hydrology plus the air quality. So these three models are combined together. Just hardly 5 minutes of where we. 3:30 is a break. We still have 2 minutes, so I'll complete it 2-3 minutes. So this is a GUI-based model or simulation what is being provided, and this helps in forecasting for our municipal corporations, the IMD, the WRD, the different disaster management solutions, right? And they have integrated with the platform for data acquisition, modeling and simulation, post-processing, visualization, and the decision support system, along with the local government. So these are kind of a collaborative approach what we work for the actual at the ground, right? So next we have a flood forecasting warning system. This was done on the basins of rivers like Tapi, Mahanadi, and Ravi. These are 3 rivers in India. And this was a pilot project where it was done, and they were able to get the flood warning system of something like 3 hourly flood propagation for next 2 days. So a daily inundation spread and water depth at every location, village level percentage-wise inundation information, and it's multilingual. Obviously, every state has their own language, as sir was mentioning. So if you want the users or the actual common people to be aware of it, it has to be multilingual. And these are the main benefits. Okay, these are the main benefits what we've got through this particular SIMI SIMINU, what you call the flood early warning system. And then the oil and gas exploration system, we have a SACE RTM visualization package, which is on par with the actual market-based systems. Okay, so this is the kind of different variations which are available, and the generated stacked image, and this is being used by the oil companies in India. And this is even available at a price for the support or open source also for the companies which are using the oil and gas companies. And then we have the materials and computational chemistry, where they have developed multiple models and softwares. So these are the list of softwares developed by different professors, which are ready to be used on a petascale or currently scaling on a petascale, but ready for an exascale kind of a machine. So these are the list of these softwares which have been developed in different materials and computational chemistry kind of discipline. Thank you. With this, I end my presentation. If you have any doubts or queries, I'm open to it.
Thank you, Deepika, for comprehensively covering all the system softwares that are available with C-DAC. We'll have a break now. We'll assemble back at 4 o'clock. Then we have a session on AI, HPC-AI, what we are doing in HPC-AI, and then HPC-Quantum. So I request all of you to kindly come back on time so that we maintain the time. Thank you very much. We'll take a break. Those who are online, for them, just the information that we are taking a break for half an hour now.
data and model innovation. The second one is advanced capabilities and applications, which includes compute as well. C-DAC is the implementing agency for National Supercomputing Mission. The third one is the explainability and transparency and ethical AI and privacy, integration and future technologies. Unless our research in AI reaches the masses, so there is no use of it, right? And evaluation and benchmarking and various capacities we do, like for our Indianized AI models, which kind of hardware suits well, right? So for example, if you are building a foundation model for English language, what level of quantization it requires, and if you build a foundation models for Hindi language, what level of quantization is required, right? So they are not same. So we have to put some technical evaluation benchmarking part in those aspects, and what kind of hardware is more suitable for our Indian languages and our Indian models. I have. Sorry, the slides got stuck. Yeah. These are some application domains, not comprehensive, not the full list. What we are working on, AI for mental health, AI for cybersecurity, as well as the secure AI, AI for agriculture, AI for language and heritage computing, and AI for automation and responsible and ethical AI. And of course, the last one is HPC-AI. This is one of the framework what we have developed is Trust AI framework. What it exactly will do is, once you develop an AI model, that model, before going to the deployment, we have to do a 360 degrees adversarial robustness assessment. What do you mean by adversarial robustness here is, if there is any precision change in your data by chance, whether your model perform with the same accuracy or not. So that is like natural attack. So what if someone is able to enter into your network and has an access to your model, and he tries to play with the weights of your model or the inference data which is coming into it? You want to do the data poisoning or model poisoning. In those cases, whether your model can withstand against this and perform with the similar level of accuracy or not. So before deployment, your model and data can be uploaded into this framework, and we do a comprehensive evaluation against every type of attack which is published in NIST security framework as per the NIST standards. And then we will give you a comprehensive report. So that tells you whether it is ready for deployment or not. If it is not ready, we also, if there is any vulnerability in your model or data, so then we will clearly indicate the risk score. Based on the risk score, we also advise a mitigation strategy here to make your model robust against those vulnerabilities. So this is one of the very comprehensive framework we are have. The second one is AI assessment framework. This is a very, very important for any of the safety or security critical applications that should not get into the deployment. This is one thing what we have developed. Like, for example, if you are developing a computer vision applications, can it withstand against common corruptions? Common corruptions means fog, maybe like weather conditions or geometric transformations, like if it is image is tilted, whether it can able to perform well or not. So we have 45 plus algorithms in-house built and parallelized for different hardwares, including AMD and NVIDIA, and even for CPU. It works on all three architectures. And you can completely simulate it and see like your own model, like which you feel it, like which you have assessed and says 95% accuracy, if it is giving. If one of these corruption happens to your inference data, what happens? Whether your model can stay there or it will come down. So that simulation we will do with a very high scalability across hundreds of nodes. We can scale it. And similarly, the model reliability. Model reliability is having two aspects. One is whether it is really performing as per the required functionality what you have defined in specs. So that functionality verification can be done, and the robustness can be done, even the calibration can be done. So a lot of other aspects you can see here, what are all against we are evaluating a model. This is the second step we do. The third one is uncertainty. Uncertainty comes from two factors. Uncertainty comes from model, uncertainty comes from data. So both model and uncertainties we can quantify, and we can give you, like, for example, if there is a out of distribution data is used for training your model. So we can easily, we have in-house developed algorithms which can detect, look, your data has OOD of, let us say, 12% or 20%, 30%. So your training data is not good enough. So maybe we have to go back and look at your data and retrain your model and come back. So this kind of assessment can be done. Similarly, as already mentioned, even against attacks, adversarial attacks also it will evaluate. And finally, we are using a formal verification methods to certify your model and stating that it is ready to deploy. So this is a complete comprehensive AI assessment framework which we are working on. The next one, as I mentioned, this is about the corruptions, what I was talking about. I have not listed all the corruptions here. Some of the corruptions you can see here. This is your original image, right? You can see a defocus blur. It can be introduced by your camera. And other one is Gaussian blur. This can be introduced by some noise in your in any of the things. So we can see a lot of corruptions, digital changes happens in your images. So all these algorithms, we have built sequential as well as the parallel versions, which can run on GPUs, and you can simulate with your data set, and you can assess your models. And also what can be done is we can generate this as a synthetic data, and this can be added as a training data to make your model robust. That pipeline also will be given completely. Right. We can see that it is a very highly scalable toolbox what we have built. We can see I have highlighted one, like for example, brightness simulation on GPU 100 we are scaling 329 times, and MI 300 400x we got. That's a highly scalable version we have developed. It's the first of its kind, I should say, as per my knowledge, right? And of course, some of them still we have to look for the scalability may be slightly low. We are looking into it. What is the problem? Maybe the inherent algorithm is sequential in nature. We are looking into it. We can see the benchmarks here. It is highly scalable. This is also, as I mentioned, it works on CPU, it works on AMD, NVIDIA, all kinds of hardwares. At least these three we are supporting as of now. It is highly scalable. Brightness, we can see this 24x means single thread versus 48 CPUs we have used, 48 cores. So we got 24x, and we moved on to GPU, we got around 329 to 338x on 328 on, 329 on A100, 338 on MI 300x. So this is the level of scalability we got. Further, we can scale it up. We are working on it. Here the problem is the sparsity aware hardware what we need. As of now, the sparsity is not inbuilt into the hardware alone. So it is like software enabled. So that's where we are facing some bottlenecks. Otherwise, it can scale up further. The way ahead to close, this is the 20 petaflop data center, which Edison mentioned in his talk. We are going to launch very soon in a couple of months with a focus on AI as well as the scientific workloads with varied architectures, GPUs with varied architectures. It is a very good setup coming up with in Bangalore in our own office. So we are excited for that. And of course, we are, as a C-DAC in India, we are moving towards exascale. We will realize this very soon in few years. Now, we know HPC and AI is not alone. Now it has to gel with quantum. So I request my colleague Ashwija to discuss about quantum computing initiatives in India. Thank you so much. Thank you all. Any questions? I can. Yes, please. Yeah.
We have shown the industry capability of the schools. These schools are managed by or from a private platform.
One is like it depends on what kind of correction it is. For example, if it is brightness, it is highly paralyzable, right? Now, why I'm saying it is brightness, we apply on pixel level. It is extremely scalable. Whereas if I take a fog or frost, so fog algorithm normally we work on patchwise. So when we are working on patchwise, we can't get the same scalability there. And if we go with high resolution images, it is memory bound, I should say. So the benchmarks may vary if I change the data set. These images are like of size, let us say 512 by 512 pixels. You are taking. Yes.
These are single GPU.
Yes, it is a single GPU as of now. So it works on multi GPUs. We have tested on H100 also we have tested, but we want to confirm after profiling and we will put it. Yes, yes. I was referring A100. Yes.
Hello, you may have already received this question, but I'm just curious if you know of any significant efforts being put into developing a LLM model that could compete with, let's say, GPT or DeepSeek.
We are working on it, but as I already mentioned, instead of focusing on large models, we focus on small models, small language models, because India has 22 plus languages. We need an agentic framework as an umbrella and have small models in between. So Bhashini has already a lot of language models, translation models, which are in place already. Yeah. So foundation models, to frankly say, India has started. We don't have a very strong foundation model in place at this moment. We can see in the down the line in a year, very soon. The work is under. Yes, recently there was a call from India Mission came in January 30th, if I remember correctly. Call for foundation models. They have received 63 plus applications in the first round. Maybe in the second round till June we may get more applications. But as I already mentioned, in India AI Mission follows a different approach. Instead of having a single DeepSeek, can I have 22 smaller versions of DeepSeeks for 22 official languages of India? So our approach is quite different. Even hardware also, even the language models also. Yes.
Yeah.
Yes, yes.
That is one part. That's one. That is one part. We are doing for science and for bio.
Yes. So thank you so much. There are no more questions. I'll just close this.
Okay, good evening. I'll be taking you through the quantum technology initiatives that are happening in India, specifically in the context of HPC-Quantum activities that are happening. As it has already been mentioned, we have a very ambitious mission project that was launched by the Government of India called the National Quantum Mission, which was announced in the year 2023. with a total budget outlay of 6,000 crores INR for the next 8 years. The mission focuses on multiple verticals, including quantum computing, communication, sensing and metrology, and materials and devices. There are very ambitious targets that have been set for each of these verticals to come up with indigenous technology developments. With regards to quantum computing, the focus is on developing, to start with, developing the indigenous QPUs in the range of 50 qubits in the first 2 years of development, and scale it up to 1,000 qubits and more in the next 8 years or so, in multiple hardware technologies, including the superconducting qubits and the photonics qubits as such, and of course on ion traps and neutral atoms. In quantum communication, the target is to lay a long distance quantum communication network, including both fiber as well as aerial connection channels as such, with the range of 2,000 plus kilometers to start with. And quantum sensing and metrology, of course, there are again very ambitious targets that are being set out over there to come up with very high precision magnetometers and the atomic clocks as such, and separate vertical for carrying out the innovation in new quantum materials and devices as such. In order to implement this ambitious vision of the nation, there have been multiple agencies within the government and outside the government who have been very instrumental in carrying out this broad vision of making India the leader in all of these different verticals of quantum technologies. There are some logos which are there in the top of the slide, which represent the different ministries under the government of India who have been actively funding many of these initiatives. The research labs, various research labs, which are at the forefront of many of these verticals of quantum technologies, they have been actively working in many of these areas even before the quantum mission was announced, or even before the quantum 2.0 revolution has started as such. And there is again a very vibrant industry ecosystem which has been actively contributing to the developments that are happening in India. As you can see, the major global players, including IBM, AWS, and NVIDIA, they all have the Indian innovation centers who have been actively contributing to the quantum technology development as such. And then there are Indian homegrown companies like Wipro, Tech Mahindra, and TCS. These companies also have dedicated units which are actively working on multiple quantum startup ecosystem, who has been very instrumental in contributing and focusing on specific areas of the mission as such. As part of the National Quantum Mission, there have been multiple startups who have been funded with specific focus. As you can see from the slide, there are 8 different startups who have been given the initial series of funding to focus on specific contributions that will lead to the development of technologies in very specific areas. There are companies who are very good at manufacturing precision lasers, which happens to be one of the crucial things for advancing the ion trap systems or the communication systems. So there are startups who are capable of building these kind of precision laser systems. There are companies who are dedicatedly working on coming up with their own QPUs in the superconducting based qubit technology. So like this, there are multiple startups who have been dedicatedly funded for advancing the technologies in this landscape. And globally also, there have been multiple initiatives for having bilateral arrangements with different companies as well as multilateral arrangements to advance these technologies. We have the Indo-US arrangement, specifically focusing on the quantum and other emerging technologies. And like that, we have specific arrangements with the EU as well, and then specific arrangements with the Quad nations also. Like I said, there have been initiatives from different departments and from different ministries within the country on advancing these technologies. Prior to the announcement of the National Quantum Mission, also, the Ministry of Electronics and Information Technology, MeitY, has been at the forefront in funding many of the initiatives in the quantum information science as such. So C-DAC is again at the forefront in implementing all of these initiatives. And further through this presentation, I'll take you through the kind of initiatives that we have been implementing to realize this vision. C-DAC happens to work in all these 4 different verticals of quantum technologies, including computation, communication, sensing, and of course, focusing on selected quantum applications as such. C-DAC is also an important member in implementing the vision of the National Quantum Mission itself. We have been partnering with the other institutes across the multiple T hubs, the technology hubs, which correspond to the different verticals of the NQM as such. With specific to quantum computing, like Sudarshan was also mentioning in his earlier talk, we started with simulator development, which mainly targets the student community and for people who cannot afford to have the quantum computing system available for the usage for coming up with their own algorithms and applications to be developed. So this was our very first initiative of developing a density matrix-based simulator, which is currently hosted on the cloud for public usage, and it is free of cost. Anyone who can just register to this cloud tool, they can start programming on the quantum simulator right away. So we currently have more than 6,500 registered users across the country who have been benefited from this simulator initiative as such. We are also involved in developing the indigenous quantum computing technology as such, the superconducting based QPU development that has been jointly carried out with the Indian Institute of Science in Bangalore. C-DAC has been mainly involved in coming up with the indigenous control hardware. Sorry, there has been some, yeah. So C-DAC has been working on coming up with an indigenous control hardware, which is used for control and instrumentation of this indigenous QPU that sits in this dilution refrigerator here. C-DAC is also actively looking at setting up a bigger quantum computing facility using the superconducting based QPU in the range of 50 to 100 qubits. So down the line in 1 year, we are planning to have this facility co-located with the 20 petaflop system that my other colleagues were just discussing. The idea is to have this system co-located with the HPC facility and have it interconnected to run the HPC quantum hybrid workloads on this integrated facility. In another initiative, we have also been working on what are called as quantum accelerators. Like there is already a consensus that the quantum systems cannot work in isolation in the near future. We expect that the quantum systems will definitely be working as accelerators to the HPC systems in the near future. And what are the kind of technologies that are required to make this kind of interconnection between the HPC and the quantum systems seamlessly? So that is the focus, that has been the focus of this initiative. In addition to this, there has been also efforts to port the quantum circuit simulators, some of the indigenously developed quantum circuit simulators, and the widely available quantum circuit simulators, be it from IBM or Google, onto some accelerated classical platforms, including the GPUs, the vectors, and the FPGA systems. So like I already mentioned, hybrid computing has been the prime focus on which C-DAC has been orienting its efforts on. We all know the quantum computers are well suited for performing specific tasks very efficiently, while the classical computers can still deliver the efficiency with the other kind of tasks. Specifically, what we are looking at is on the development of the hybrid quantum classical algorithms, including the VQA and the QAOA, which are quite useful in tasks like optimization and chemistry and machine learning as such. We are also working on building the stack for enabling these quantum computers, the hybrid quantum systems, onto the cloud so that they will be made available for all the research institutes within the country. In this endeavor, we have also come up with an unified software stack, which can horizontally scale and which can connect to multiple quantum computing platforms as such, including the superconducting qubits or the photonic qubits or the ion trap systems as such. The philosophy has been that you program once or you code once and try to run it on multiple quantum hardware as such. So this again includes a whole bunch of the software tools that are required, starting from the algorithm implementations as part of the SDK to the low-level transpilers and the pulse generators that are required for running the code on a specific platform as such. C-DAC has also been actively working in post-quantum cryptography as such. We have a big initiative in which we are trying to develop our own algorithms to cater to the post-quantum era. And we're also looking at efficient implementations of the NIST certified algorithms on multiple hardware devices, including efficient FPGA implementations. And we are also planning to bring out our own dongle, an USB dongle, which is PQC compliant as such. And we are also having an initiative for enhancing the TLS, the SSL cipher suite, to include the PQC compliant implementations as such. In the quantum communication space, again, to start with, we have a simulator for the quantum network simulator, which tries to mimic the various quantum communication protocols, including the QKD and many other application protocols of quantum communication on the classical devices. So this could again be used as an educative tool by the students and the researchers for developing various quantum communication protocols as such. We are also part of an ambitious project called the MACAN, which is a short form for the Metro Area Quantum Access Network. We have already successfully implemented this project in a city called Chennai in India, where we have laid out a physical QKD network, and we have demonstrated successfully quantum communication between these locations in a gap of nearly around 10 kilometers. The idea is to scale and build upon this model to go for a long distance quantum communication network as part of the National Quantum Mission, where the overarching ambition is to set up a large trusted node based quantum key distribution network, which spans over 2000 kilometers, connecting Chennai to Bangalore to a city called New Delhi, which has a distance of more than 2000 kilometers as such. We are also working on using the free space communication channel. Particularly, we have been working on developing drone-based QKD networks on how to accomplish QKD with moving targets, specifically using the drones or the vehicular traffic as such. On the application side, since quantum machine learning has been spoken about multiple times, there has been a very coordinated effort from the MIT to create an interesting subgroup which focuses on developing quantum machine learning based applications, including the applications of these algorithms in different scientific domains as such. Specifically targeting the financial sector, there have been multiple coordinated efforts for developing subsystems, including the employment of QKD for securing the financial transactions as such, and also on implementing the PQC algorithms for securing the financial sector as such. Though not in a big way, C-DAC also has contributions in quantum sensing. We have some projects which employ the principles of quantum sensing for detecting the pollutants in water at very minute levels. So our center at C-DAC Kolkata has been actively working in building these optical sensors for detecting the water pollutants. In addition to these different technology verticals, C-DAC has also been looking at how to proliferate the quantum technologies and build the capacity in this area. We regularly conduct multiple events, conferences, symposia, webinars, and many outreach programs to impart the knowledge and to build the capacity and the talent within the country, so that we have a quantum ready workforce in the near future who can contribute to all the interdisciplinary projects and the bigger ambitions of the National Quantum Mission as such. So these are just some of the snapshots that we have got from the various events that we have been conducting as such. We also publish a quarterly newsletter called the Quantum Vibes, which essentially captures all the major happenings in the quantum technology space, which is available both in the digital format as well as in the physical format. So people can just subscribe to the newsletter. You can scan this QR code and you will be having the access to this newsletter, which also includes some interesting articles written by the researchers within the country. It also highlights about the different events that are planned in the future, and also the interesting publications that have happened in that particular quarter related to the various verticals of quantum technologies as such. Like I said, we have an ambitious roadmap with the broad goal of the entire vision to make India as the global leader in the quantum technologies space as such. Because of lack of time, I'll not go into the details of the roadmap as such. This vision again aligns with the broader vision of the National Quantum Mission. So with that, I try to conclude this talk. We have a very strong and vibrant team working at C-DAC, who has been instrumental in carrying out all these initiatives that I just spoken of. Any questions at this point? I'll be happy to answer. Yes.
One question from my side. We were talking about qubits.
Yeah.
Do you mean the physical qubit or?
The figures that I mentioned were all about physical qubits. Yeah. Of course, it makes sense when we are speaking about the hardware developments. It makes sense to talk about the physical qubits. So there have been efforts, and it definitely goes into our roadmap as well on how do we realize the logical qubits also at the same time keeping the physical qubit development happening in the hardware level.
No, I asked because initially when people started publishing qubits,
yeah,
they were talking more about logical and less about physical.
That's true. The history again spans to the usage of the simulators, because when the actual systems were not available, people started developing the algorithms on the simulators where the qubits were ideal in nature. So they're all again equivalent to the logical qubits. But then when you have the QPs which are available now, they are physical qubits, but they come up with noise. So that's where the progression happens. We will have to look at the error correction strategies that have to be employed in creating the logical qubits. Yeah. Thank you.
Good evening, everyone. I am Misbahuddin. I'll just give a very brief overview of the activities that we are carrying out in capacity building in the area of HPC, HPC-AI. Then immediately, in the best interest of time, we will, instead of panel, we will have a round table. And then all the members are already here. So we'll set the stage with a discussion on India's journey in HPC-AI, HPC-Quantum, and hybrid computing. And also, like NVIDIA is there and other organizations are there. What, from your organization perspective, what is that you are contributing to India's journey in HPC-AI? So that will be the focus of our discussion. Yeah. So I'll quickly just walk through what we are doing in the area of capacity building. I'm just skipping see how we have provided the package in capacity building is there are three things. One is HPC infrastructure that is required for the students as well as the researchers. And the second one is the application development or the simulation. Okay, so both they have already covered in the previous presentations. And then the third one is the capacity building in the area of HPC and AI. So till now, just a brief recap. If you look at with the postgraduate diploma courses that we offer for 6 months duration, and the minor courses with many of the universities as well as the premier institutes like IITs and ITs, and also some certificate courses that we have offered. So total around 23,000 candidates have been trained across India. India is a diverse country as well as you know that there are around, you might be aware that there are around 29 states plus union territories. So it totals about 36 to 37 states and UTs together. And then if you look at, there are 1,000 candidates who are pursuing PhD in the area of HPC, and then there are 1,500 plus publications. And very recently, we have also created a content in blended learning mode along with IEEE. So in fact, IEEE, their blended learning platform is running on our Param Utkarsh supercomputer. So we have created 4 basic courses. Just we have launched it 2-3 months back, and as of today, some 3,000 students have taken up that particular course. It is very basic. Even the school children can also understand what HPC is, what is parallel architecture, and what is parallel programming. And continuing with the different versions of our capacity building programs, we have recently established a center called as Center for HPC Upskilling and Knowledge Sharing. So through this, we are conducting advanced certificate courses. In India, we have the Ministry of Skill Development. They give the affiliation or certification called as NCVT certification, National Council for Vocational Education Training. And they have the recognition across India. And beyond that, they also recognize the credits that the students get. So that many of the international universities can also, recognize their credits, whatever they are getting. So it is not that they are simply getting upskilling program, but also they are getting the credits, which helps them in their further career, academic career. Now, this 6 months training program, we have till now conducted in HPC-AI and HPC cybersecurity. In last 1.5 years, we have trained around 300 candidates. One important thing that I want to highlight here is this is a grant-based thing. And the funds that we have received, we have offered these programs free of cost. While if you look at the industry there back in India, in HPC-AI, the courses for 6 months duration costs around 200,000 rupees. So 200,000 to 250,000. Okay, so these programs are offered free of cost. On top of that, monthly stipend is also given to them, and then course material is free. That means a student who is willing to learn, he just need to enroll and then join the course. So these all are offline courses that we have offered. And the faculty development program, you know that because of the fast evolution of this AI, the students have, at least caught the little bit race, but comparing to faculty members, they were taking a little bit of time. So we started training the faculty members as well. Until now, we have trained faculty members, around 300 faculty members from around 20 states across India. And then there was a request from AICTE. AICTE is All India Council for Technical Education, which is a policy-making body for all the engineering colleges as well as professional bachelor's and master courses in India. So they have come up and then they asked us to conduct the master trainer program, because they said that they will nominate the faculty members who can be master trainers, and then they go back and region wise they can train multiple other faculties. So again, 3 weeks master trainer programs we have conducted, 4 master programs we have conducted for a duration of 3 weeks, in which 1 week was online and then 2 weeks of offline. And all these courses, wherever I'm mentioning, in every course, we have given the access to our Param supercomputers to any of these, whether it is a student or a faculty member. Now, with the success of this master trainer program, the AICTE, which is a regulating body, they have come up to us and now they're requesting that across India, there are 29,000 engineering colleges that are there. And there are more than 200,000 faculty members who are qualified PhD holders across India, and they need training in the area of HPC. Now, very soon we are going to start the trainings in that particular area. So this is, I have already mentioned how the distribution was. So faculty, I'm just skipping this because I've already spoken. And testimonials, if you can go to c-huk.cdacb.in, you will get all the details of this project. This is what I was mentioning about the blended learning content that we have created along with IEEE, and it is available on the IEEE platform. Now the new activities that we have already started, and this year we are going to complete these activities are practicum. Practicum is the one wherein if any candidate has a little bit of knowledge of programming and wants to understand more about HPC and HPC with, again, different flavors of HPC with AI, quantum, or RISC-V design. So 1 month of training will be offered to them, and then 3 months of projects, hands-on project, live project, the students will go through. And then on-job training, I was talking to multiple industry partners also here. So we are going to send some 10 to 15 candidates to each industry organization, where they will be trained by the mentors there, okay, for a month of, for a period of 4 months duration. And all these activities, again, are fully funded by Ministry of Electronics and IT, Government of India. Experience Center is the one which we are going to establish at 4 places across India. In North, South, East, and West, we have identified the institutions. So this HPC Center, like what you have seen, the Tech Expo that you have seen just now, the exhibition. So similar kind, each and every aspect of the supercomputers, the AI, quantum, everything, be it hardware, software, or simulations, everything will be put together in a single area. And C-DAC, one center I'm talking about, we have 12 centers across India, one center every year have a normal, average footfall of 5,000 to 6,000 engineering students who come to C-DAC just to see our developments and softwares, the indigenizations that we have been doing. So around 60 to 70,000 across India will be minimum, will be visiting C-DAC centers. So this experience center is going to give them a live understanding of how HPC works, how AI works, and quantum works. So we are going to establish this. The target is before December, we are going to do this. And experiential learning is a kind of faculty industrial immersion program. So we started with 5-day faculty development program. Then the faculty members came back to us. Then they said that it was kind of a basic. We want to get into more details. Then we offered the 3-week master trainer program. Now for more details, for more detailed courses, now 4 to 6 weeks we have identified as experiential learning for master students, PhD scholars, as well as the faculty members. They are going to come, stay at C-DAC for 4 to 6 weeks, and then work with our HPC experts. And then an exclusive e-learning hybrid platform will be developed for those. There are many requests that have been received by C-DAC by those who are already working and they want to upskill or they want to get into new area called as HPC-AI. So for them, they don't have time. So they want some content that is provided, which is a self-paced content. For that, we are going to have the e-learning hybrid platform. And then finally, expanding horizons, this particular SCA conference, our presence here and invited track here is the first step towards that journey. So in a year, we are going to represent C-DAC in 4 such conferences outside India. And also, as it was mentioned in the beginning as well, that we are going to have our own SC India version in this year. Most probably it may happen in September or December. We will notify it very soon. We are having discussion with IEEE. So these are the details of those programs that I have already mentioned there. And there is a new education policy by Government of India. So all our courses are aligned with the new education policy of Government of India. And this new education policy has an entry and exit system that if a student wants to, he has taken our advanced certificate course of 6 months, then followed by, he is also interested to get into practicum and followed by OJT. So it will be a total of 14 months. So now AICT will come into picture and they will recognize their diploma so that industry, not only industry readiness, industry acceptance will be more. So that is how we have identified and we have actually planned the entire thing. So finally, if you look at the collaborations that C-DAC is having in order to implement this, IEEE because of blended learning and also the wide outreach that IEEE has, then new education policy implementing agencies and also state Department of Social Welfare. If you look at inclusive capacity building, the C-DAC with this CHUG program, Center of HPC Upskilling and Knowledge Sharing, we have we have done very well in this. There are many marginalized communities in India. So these programs were offered to the marginalized communities and they have been covered under this through the social welfare departments of all the states. So, and then in the Northeast and other regions also, we are going to conduct this. And there are industry collaborations with NVIDIA, AMD, HPE, and many other companies where, as I mentioned, that we are going to have our experience center with them, experience center, as well as the practicum and OJT programs. So I'll conclude here. And I invite the members to kindly join here. Can I request Ramesh? We'll make it as a round table or we'll just turn the chairs and then we have for our panel, Vel Berkovich, Head of AI Products, Vika. I invite you. And then Mr. Tapan Joshi, Senior Director, Tenstorrent. Can we make it as? Yeah, thank you. And Dr. Manish Mudani. Manish Mudani is the Principal Solution Architect, NVIDIA. And Dr. S.D. Sudarshan obviously is here, Executive Director from C-DAC Bangalore. And I hope Mr. Parminder Singh is there online. Yeah. Mr. Parminder Singh is Associate Vice President, Vividian Technologies. Basically, they are into the manufacturing of our Param Shavak supercomputers. So first of all, I request you, can we give the mics to them? Yeah. Yeah. Dr. Manish. Yeah. To set the agenda, as I have already mentioned, first of all,
The projector off or?
yeah, we can switch off the projector. Yeah.
Or
We have 30 minutes time for this panel discussion. My request is first 1 minute each of your introduction by yourself, and then followed by setting the agenda of talking about the India's journey in HPC-AI and quantum, and then your company's contribution towards that development.
So, good evening all. Well, thank you for being here. My name is Sudarshan. I'm responsible for Bangalore. First, thank you for being here. The last day, the last session. But this is where we start the next journey or the next event and going forward. Nothing happens without collaboration today. And the whole team here. The idea is to tell them that what we have achieved and what we can do for the. And from C-DAC side, once upon a time we were rigid, like we were silos. R&D level is to talk, there are a lot of things have moved on. Today collaboration can be a lot of openness has come. And we are also with the support of the ministry. We are able to be part of various international organizations. Being able to take forward the country's vision to bring a better economy, better life for the society and large. And this collaboration is very, very important. So, I give us it more than like now you can introduce yourself maybe a little, I think there's few bullets to fire. And it's for you to handle. And if something goes beyond, then I'll come and rescue you. Thank you so much.
So I'm sitting at a wrong place.
thank you for that. So I'm Val Berkovici. I represent WECA. We are a big NVIDIA partner, and we are in the storage and data management space. We ship an AI data platform. My personal background is I've been involved in cloud since the early Kubernetes days. I helped create the CNCF for the Linux Foundation. More recently, we're working with the Linux Foundation project VLLM, Virtual LLM, and bringing some new KV cache solutions to the marketplace that dramatically accelerate inference. In terms of the contributions to India, we're a very small startup still. We're less than 500 people, less than 200 in engineering. About a quarter of all of our engineering is in India and Bangalore. We have many customers, some government, defense customers, life sciences, and similar customers with very, very large clusters, GPU clusters in India, as big as Elon's cluster, as big as Colossus, for example, and some very, very large storage systems in that. So we're very happy to support, employment in India, the advancement of AI in India, and certainly, good business in India as well.
Hi, I'm your partner. So I'm principal solution architect in NVIDIA. My key roles are technical lead for 4 key India mission, that is National Supercomputing Mission, the Quantum Mission, the National Monsoon Mission, which is weather, and the India AI mission now is started with that. So I'm technical lead from that side. One more program I manage is NVIDIA Technology Center, where we enable any faculty for their research project to get success. So we work for them for a couple of years during their project and make them successful. So now coming to the contribution side, C-DAC is my primary technical account. I'm a technical account manager as a part of NSM. We are doing the 4 key pillars where we are contributing. Certainly the system, when they come up with system, we certify those with our new GPUs. We enable design networking, that's that part. And coming to the application side, we work with C-DAC team to
have the best practices, how to optimize the application of new architecture. We perhaps be one kind of architecture where DJs are there, then Rudra is another kind of architecture, which is HDX kind of system, what we say. The third, and we take few applications also to make them GPU accelerated. Today we discuss Anuga, that is also GPU accelerated. We discuss QSync, that is also GPU enabled. So we work on niche application to make them GPU enabled, and the ownership remains with NSM or C-DAC. The another part came is skilling. So last 4 years I am in MBA, and we are working closely with the skilling part. We every year conduct sessions where we do hands-on session on NSM system, the best practices how to run a commonly used application, with molecular dynamics, CLD, weather, and so on. Now we are moving towards AI, we may bring everyone towards AI. So we teach the course starting from computer vision, NLP, to LLM, GenAI, and all. We do have our program, Deep Learning Institute, DLIs, which is one-day certification tool, which we provide the platform for hands-on, and after it also get certified. That also we run for with C-DAC continuously for 10 weeks, which is generally chargeable as well, but for C-DAC we try to go to. Last but not least, the key component now is startup and dimension. So there also we are working through our inception program, bringing more and more startup to C-DAC, be it outside or be it the C-DAC Bangalore system, enable them on the system and try to address the issue. With that, for India, would like to work more to have what you say, make in India applications, Indian data remain there to enable them, and working with government and answer. Looking forward for more. I can give more details. Let's read a short.
I think Mr. Tapan.
Sure. So my name is Tapan Joshi. I represent a company named Expo. We work in the same field. I think, okay, about my background, I've spent more than 2 decades in the industry, majorly focusing on embedded systems. Started with hardware, then moved to software, and then last couple of years, close to 9.5 years into AI systems. I worked for a company before called Blaze, where I built the entire software group. So back to Expo, right? And how our vision is aligned with self-reliance, right? I'll not use the word, but that is self-reliant, right? Like many other countries, India would like to become reliant on its own technology, right? They want to own the IP, own technology. And our ethos of our company is exactly the same. So we started with RISC-V-based design, right? Our complete design and the software is open source. So anyone can go to GitHub and download our idea. Anyone can go and download entire software stack and start building applications. We provide the cloud instances to our users, which can be developer community. So we have our own developer community, right? Which we have built up, and I think we have a couple of thousand developers now, part of the community, contributing into RISC-V-based ecosystem. So it aligns very well with what we are trying to accomplish here in India, right? The self-reliance, the RISC-V-based system, the open system. We don't need to worry much about licensing an IP from someone which can hold you for ransom, the way we saw 2 organizations fighting in the court for that, right? So that's how it goes, matches very well with what C-DAC and India as a country is trying to do. Skill development. Dr. Musbah talked about it, and I would like to give one example in particular. So Japanese government has approached us for the skill development program. And Telstra officially is going to train 200 chip designers on the latest design, right? So this is a 5-year program that we are running. So we are already into the cycle, contributing to the society in one country in the geography. We are nearly 800 people, right? So we are in the startup mode. We do not have that much of manpower and possibility to go across the geography and do certain things, but we are doing what best we can, right? The open source community, developer community, contributing back to the society, right? Similar thing we have spoken and as far as possible, we would love to do that for India as well. We have set up an office in Bangalore. We are 60 people strong there, mainly focusing on design verification and DFT. We are planning to expand that team into the hardware design and going forward to software as well. So yes, that is on the utilizing the skills that India has. So I think I'll restrict that.
Yeah. Thank you, Tapan. Can I request Parminder to introduce yourself as well as talk about what VVDN is doing?
Yeah, so my name is Parminder Singh. I'm part of VVDN Technologies. I am part of VVDN Technology from past 6.5 years. So, talking about my background, I'm whole completely a IT background person, right? Working in all IT sectors till now. So I will focus, I think, on the organization VVDN and what VVDN is doing here in India. So VVDN Technologies is a ODM. So we are original design manufacturers. We are into providing premium engineering services and manufacturing services. We have close to 6,000 R&D engineers with us, and we have 6,000 people working in the manufacturing side. When I say R&D, we are the brand sitting behind the brands. So we are the design partners to all big brands globally, whether it is, and we are also the manufacturing partners to all big brands. Now, if I focus specifically on the IT side, we are the manufacturing partners to the C-DAC, right? We are the manufacturing partners where we are manufacturing the Rudra servers, which are designed by C-DAC, and we are manufacturing those Rudra servers for C-DAC. As today in the starting, ma'am Sunita ma'am mentioned about the Param Shavak. That is again a high performance computing system, HPC system, which can be used on a tabletop, right? Which is again a indigenous product designed by C-DAC and VVDN, manufactured here in India. So that product is completely 100% made in India product. Similarly, we are also working very closely with C-DAC on the design side of the HPC and the AI servers. I think Sudarshan sir is there, so we are working very closely and the joint design partners for designing the AI servers, which are the 8U AI servers, AMD based, and also the 2U servers. From the manufacturing side, right? So today for VVDN Technologies, our only dependency is the electronic components. Rest everything is done here in India. From the complete design till the taking the design to the software, complete hardware, and then taking it to the prototypes, and then taking those prototypes into the mass manufacturing products, whether it is PCBA or the injection molding, sheet metal facilities, die casting, the testing part, everything is done here in India for all the products. Now, if I say the contribution, our contribution towards the Make in India and the future of the HPCs, one is the server side. We are also working with the C-DAC team on the Intel based servers, where we are the manufacturing partners to the upcoming series also for the C-DAC side. In the same segment, we are also the manufacturing partners for HPE and the DDN, where we are manufacturing these HPE servers here in India for HPE. So that is the manufacturing side with respect to the IT segment, where we are working very closely with all big brands and C-DAC and the Ministry of Electronics and IT. Other side of it, so we are also working in different business units where we are into the 5G side, where we are working on localizing all 5G radios and the antennas. Then the IoT products, all IoT laptops and tablets. So we are the only company here in India who has designed their own laptops without the dependency of any third country on the design or on the manufacturing side. So then we are into networking and Wi-Fi. We're doing all kind of networking and Wi-Fi products. Then the automotive side, where we are also, if you see here in India, you will find Mahindra cars now coming up with the products designed and manufactured by us. And that is again the 100% design and make in India products. Similarly, with all global brands, whether in India, US or Europe. So we are working for them, designing products here and manufacturing and then shipping it out of India to the global companies. So that is one motive or the agenda which we are carrying, that designing and manufacturing here and shipping it globally. So that is what the organization is today. And we are also focusing on the backward integration, where when we say the localization part, we will also be coming up with the PCB fab manufacturing here in India. We'll also coming up with the display manufacturing here in India. We are having the North hub where we have all factories here, and then the South hub. So that is the overall of the organization, where we see as the only organization who is into the design side as well as the manufacturing side. With C-DAC, yes, we are working very closely in the design and manufacturing side, whether it is the IoT products or the HPC side. We are the server, storage, and the other products. Yeah.
Okay, thank you, Parminder. I'm seeing Naveen Kumar from HPC Division Mighty. Naveenji, are you there? If he's here, then we can connect him. Okay. Meanwhile, to continue with our discussion, it's an open question to the panel. We have been now talking about HPC-AI Quantum, kind of hybrid computing. So two things that are coming to the mind is, number one, how soon we can see that? Okay, or how far is it? And suppose, and when it comes, then how efficient, energy efficient it will be. So over to the panel.
I am not a quantum expert, but I can say that 7 years ago I wasn't a machine learning expert, and 3 years ago I wasn't a Gen AI expert. So what I do know for sure is that we're in the before phase, the before ChatGPT phase of quantum. And when there's enough practical applications, from what I do know, a few thousand logical qubits, it's going to be that ChatGPT moment, and there's going to be tens of billions of dollars, if not hundreds of billions of dollars globally invested. So now is the time, of course, to invest early, as NVIDIA invested early, both in GPUs and in quantum and related technologies, and it's an exciting time. I think it's difficult to just wait for a breakout moment, but inevitably will come, because again, we have the ChatGPT example.
Well said. Like to add there, quantum is becoming reality. Is there when we are waiting, but the time is there to be quantum ready. We have enough tools now, enough system now to do. One side we say hardware not ready, but other side of the picture is applications ready. They are not ready. Future is going to be hybrid, in the sense program will start, and program will start on CPU only. Part of it will go to accelerator, the current accelerator, the CPUs, FPGA, GPU, FPGA, or any kind of thing, and part of it will offload to the quantum. So are we ready with any application which can run like that? So that is the need of the hour. I feel that is more important. And certainly it will be energy efficient, because if you see traditional HPC versus AI, or traditional supercomputing job versus AI, the AI, when it runs in inferencing mode, it takes very less energy. Be it in weather forecast, be it CFD or any domain. AI takes very less energy because it requires very little time. Instead of 6 hours, it can finish the job in 2 minutes. So that is energy efficient. Similar way, quantum will also be going to be energy efficient. So yes, quantification, I do not have answer, but yes, we are seeing that is going to.
Makes sense. We as well are not into quantum, but we are definitely there in HPC and AI, right? We do, because we do both RISC-V CPU as well as the AI co-processor, right? And worth to note that we would be the first company to bring the A to Y RISC-V based CPU first in the world, right? So I can talk for that section. I'm an enthusiast on the quantum side. I hope that quantum ecosystem will be built, but I think we are far. To have meaningful number of qubits, right? To get the result what we want, I think it is going to take a couple of years before we can. And it is not about ensuring that hardware is ready. Do we have rest of the ecosystem, like you mentioned, right? Not only the application. the algorithms are going to be different, right? It would not be the same way you are writing today's algorithms. You are not going to write quantum algorithms at the same time. So you have that whole ecosystem. One part of the society or set of companies are trying to build hardware, right? Now, the rest of the ecosystem should also come up. There are applications, right? There are areas where we have a lot of compute to be done, thousands of possibility to venture through, and quantum is going to help us. Now, how to integrate HPC and AI plus quantum? We have seen the integration of HPC and AI already. It is successful today. I think a lot of companies and a lot of data centers are already running it. I'm hopeful about quantum. It is going to take its own course of time. I cannot quantify as well, saying whether it will take 5 years, 7 years, but I'm looking forward to it. But for that, again, we all need to work. We need to see whether we can be an open ecosystem, right? Can come up with an open standard for quantum as well, the way we are bringing in with RISC-V, etc. I think, yeah, looking forward to it. Power efficiency, the last one. My fingers crossed. But yes, like we have improved in every other system in the past, I believe we would do the power optimization also in the quantum-based system.
Dr. Sudarshan, I think. Ravinderji, you want to add something?
I think the other members has already covered major part of it, because not of from the quantum side, HPC and the AI side with respect to the hardware side, yes, definitely. When we are now getting into the designing of such hardwares, we are definitely working on from the build side, that we take care of that part, right? That where the systems are designed effectively, wherein we can take care of the energy efficiency and use less power. So that work is going around. Yes, we are also part of some of the key projects where we are also working on that. I think that is one of the challenge which has to be taken care of, which is still open, I think, till now.
I think,
yeah.
Okay, I'll speak last. Maybe I'll ask one question to each of your target, rather than generic. See, the whole ecosystem has built up from bottom up. And in the end, we are getting into manufacturing. Maybe we'll take the questions in reverse order. So, Parminder, when you started manufacturing a HPC server, which is a different class and different breed, it is not a typical desktop. It's not another. There are a lot of criteria in terms of precision and the quality control. Finally, the benchmarking to achieve. Now, what are the challenges you went through when you did it ground up? First time, there were issues with our team also, for us also first time. What made it successful today that you're able to deliver? Just if you can share that.
Yeah, so see, when we started, so the first project which we started was the DDN, and then we got the C-DAC Rudra server. Now, when we got that project of for manufacturing the Rudra servers, the first challenge was the availability of the material, right? So I mentioned in my earlier talks also that the electronic bomb, that was the one major challenge, which is even today it is still there. Now, as we get involved more into that, we were able to take care of the challenges which were related to the mechanical side of the machine. Now if I keep aside the electronic parts, rest everything, it took some time, I think approximately 1 year to find out the vendors, or the build the vendors for the raw materials, for the hardware part, and hardware includes the plastic part, the sheet metal part, and the die casting part, which were used there. So that took us around 1 year, right, to explore the vendors, to test the quality of the products and the quality of the material. We made multiple prototypes for those, and then finally, after that, came on to the final machine, or the final products, which is now being used and are working very fine. So yes, that was a learning curve for 12 to 18 months, and and learning as well as the experimental work, where we were not from the design side, but yes, from the manufacturing side, finding the right set of vendors, aligning with them, using the products, making the product, and testing those products in these environments where it has to be used. Now, the environment also plays an important role here for the HPC type of machines. Yes, that was a challenge, I think, which we overtook. We took around 12 to 18 months to come out of that, and now we are very confident of any of the machine. It can be a 2U, 6U, or the 8U machine. Now, from the non electronic side, yes, we can do any set of machine and product.
So the 18 months learning now will become like the inferencing. So it's going to be 6 hours before minutes, right? Going forward.
Yes, sir. So now the ecosystem is in place, right? Now we know that in India itself, from where, what quality of material is required, and how much time we will take to build that machine.
Thank you. So
Help us about localize it.
many of us are talking about how do we build ground up. So getting a sourcing of all the components and materials for anything that will be of production quality is a major challenge. Because there is one learning people want to take, and have been talking to Taiwanese, Indonesia and others. They are also going to come up with a similar model. So thank you for that. So before we want, Naveen sir, you have raised your hand. Any specific topic you want to speak?
No, it is not that, sir. That was not. He didn't raise his hand. That was a cursor, actually.
So now, we look at how do we do the production or how we can do the manufacturing. Whatever is produced is based on the hardware side. So maybe we have one CPU, one GPU, both are here. So we'll hear from the CPU side. Why do you think RISC-V is the right approach for HPC? And how do you think this will align with at least AI, if not more?
So first of all, I'll answer why RISC-V, right? It's a community which has come up together. We have a lot of contribution. So I would say it would have been something else, right? Which has become an open community, a lot of people contributing into it and producing products based on it. So today we see RISC-V based design. I think NVIDIA is also venturing into RISC-V
Okay.
So yeah,
And
it's not only the CPU, right? So we use RISC-V cores also in our AI processor cores, right? So we use it for data management, right before data goes into our computation. So we use it for both purposes, the pure CPU as well as for the data management in the AI process. So one, there is ecosystem. We see a possibility of creating that open system for everybody to contribute, and we contribute back to the community. So it is more of an approach, right, of an open community, OCP being the other one, right, that we see in the industry. And there are many others. So we want to create a system where it is not tied to a company, not tied to an IP, not tied to only a licensing model. But people come together as a technical community, build together, contribute together, and make better systems. Of course, people put an effort, put their money. They are going to take some royalty out of it. There is no free business, I agree. But the main ethos is about bringing all the brains together and making a better product, right? It also comes in a different, like we internally use a term called ideas, right? The areas where we are measuring. And the last S means sovereign, right? A lot of companies want to build their own IP or want to own their IP. So this kind of community contributes into that. And India being one of that, one from that category, I think we are contributing to this issue as well.
Yesterday, not yesterday, day before, CPU NVIDIA was talking about GPU versus AI, kind of with DeepSeek in question. So maybe this is a question to Dr. Manish. Earlier, the GPU, which was a kind of a general purpose, people tried to use for pure play AI. And when the pure play AI used a very specific, more optimized one, because the use cases are very more, that became much more efficient, and we are talking about it. So what do you think going forward, will GPU and AI accelerator will be two different segments? Or you think your GPU will become more AI focused and somebody wanting to the traditional HPC GPU will pay the penalty? Where do you think the industry will go? What will be NVIDIA strategy? You'll have two variants or you'll push everybody to AI? What is it?
Great question. So before that, I would like to set some analogy how evolution comes and little bit about NVIDIA also. So far I was talking about it. So NVIDIA started in 1993 as known as a gaming company.
Yeah.
So, and then in 2005 we came up with CUDA layer, which could exploit the gaming cards for number crunching. And that's where HPC journey started. Still 2012 and all, I was in IBM that time, we were restricting on GPU are useful or not. Only FFT gets uploaded. It's good for that one kernel, but not for application. Then architecture remained there in 2012, the AlexNet competition, someone won it from Canada. Then we show that deep learning is very good on GPUs. And that time the revolution happened. The AI ML DL things started on GPU. Of course, our CEO is very quick and he made all the company aligned with that. That is another, but things have started from there. Now the architecture remained there, then GenAI came into the picture 2016, 17. Again, architecture was there, all evolution there. Now the quantum time started. Our architecture is there, one can do the simulation now, be quantum ready, and we are expecting new revolution will come. Okay? Now it's a need basis, sir. I come to your question now that where the NVIDIA is heading and how we are addressing the demand. So it's a demand driven. We see earlier HPC was there, so our cores were going for FP64, FP32 to some extent. Then we started, okay, market is driving towards AI, so we are with Tensor Core more towards FP16. Now we are coming with the FP8. Soon we may have FP4 also.
Okay.
On GPU. Right. And already we are converting all the training towards FP4. DeepSeek is good for us, the market lead other way around. But DeepSeek is good for us because whatever they did on NVIDIA GPUs. So we like the NVIDIA ecosystem being used, right? And we can now converting inside even NVIDIA models, many training models, we are trying to convert FP8 to FP4. That work is going on for India in India. So it's a market driven. We may come up with, so far we are trying to have one GPU which address all the requirements. But if HPC requirement comes even more, then again we may think of HPL side of the story. But right now what we are doing is more towards AI side, and we are doing emulation to address the HPL kind of requirement. And I'm coming more HPL because supercomputing side, generally HPL is the key. Still the measurement goes with HPL. So we say HPL is not the right measurement, but still we need to follow what market says. So there we are providing the emulation. So the need is the necessity is the for the emissions. We are following. It's a market driven.
I think wants to
so-
just interrupt you.
This is actually amazing. See, this is something we all have been thinking. It's the news is anti, but it is actually pro.
Yeah.
So that's very, very important. So Naveen sir, you want to add anything? We saw you briefly enjoying the ride.
Yes. Can you hear me now? Yeah. So this one, sir.
We can hear you, sir.
Yeah, I was listening to all of you. So actually, I just want to add that, under the supercomputing mission, since we're talking since morning about this initiative of Government of India, wherein we have deployed around 40 petaflop across the country. And in the next 6 months, we will make this compute to around 64 petaflop. So after this year, in the next year, we are planning to build a exaflop level machine, in which we will use our indigenous technologies. Like we are talking about some Intel and AMD based server boards. And we are also talking about RISC-V developments, where we will build our own CPU, GPU, and now kind of things. So I want to ask a couple of questions. Since we have Parvinder also, we have people from NVIDIA also, Mr. Manish also. So Mr. Parvinder, do you think is India ready to basically build the kind of servers we require for making a exaflop level machine? Suppose we will build our own servers based on AMD and then Rudra on AMD, then Rudra on Sapphire Rapid. Also, we will also make our own board using RISC-V. So do you think, do we have the enough manufacturing capabilities in our country to make an exaflop level machine?
Sir, see, from the manufacturing side, the capability is already there with us. Now, since we have already manufacturing the machines which are already part of the supercomputers which are already running in the country. So the capability wise, whether it is from the PCBA or the plastic parts or the sheet metal parts, yes, making all the components, manufacturing all the components here, the capacity is already there. Second comes the making the machine and testing the machines. The testing setups are already there and in place, and we are already doing it for the global brands. So the learnings from the global brands and the learning from the initiatives taken by the government of India, the capacities are already there, and we can build any kind of machines and can build any number which we want to build from here.
Because in the current mission, basically we have seen there is a supply chain issue we always faced whenever we go for building our own Rudra servers. So,
Sir, supply chain issues, if you see, I already mentioned the electronic components. That is where I think the issues comes up, where we are importing the components from outside India. Still, I see the 50 to 60% of the components being imported from outside India, and which are not the logistics and the issues is this is where we face the issues. I think that impacts only the delivery time of the production time, but that don't impact the capacity. So when we say the capacity for building the machines, it is already there. The supply chain issues may affect the delivery timeline, but not the capacity to build it. It is already there.
okay, thank you. So I think we have a member from 10 student also.
Yes, sir, please go ahead.
Yeah. So my question to you is basically, you must be aware we are, as in government of India is also promoting to build our own GPU, and wherein we based on RISC-V technology, CPU, GPU, NOC, and accelerator. So how Tenstorrent is basically ready to take up this such kind of challenges? As I know that you have built some IPs based on RISC-V. So can you just throw some light on this? How such C-DAC and industry collaboration can be made along with some industry like you?
We want to build this by CPU, GPU in India.
Okay. Good question. I think I mentioned it very briefly at a very high level to begin with. We are expanding our teams in India. We have a design verification and DFT teams in India. We just started just 2 months ago. We decided that we are going to build our physical design group also in India. So currently it exists only in the US. So slowly, and we know there is a huge talent base in India. I have myself experienced because we built AI IP out of India 9 years ago, right? Where skills were not available. I literally struggled. I got verification guys, right? Compiler verification guys, and converted them into compilers, right? By training, etc. So now we don't have an issue because institutions are coming up. They are building their own programs, right? They're advancing their programs, and hence we have skill base available. So we as a company are spawning into all areas of design, verification, the labs. So slowly, we have our own roadmap to build those teams in India. And eventually we will have not only the verification which we are doing today or physical design that we have started doing in Bangalore in particular. We are going to extend that to software design, software verification, and other areas to build a whole product out of it.
Yeah, thank you. In the best interest of time, I think Mr. Well Berkovich has a flight to catch.
Yeah, so
Right,
maybe one question I will quickly, and then Veka is into the software that enables better access to storage management, many other things. At the end of the day, the hardware capacity is limited by how the software can exploit it. So what inputs or enablement you are doing, given the diversity of underlying hardware that is happening? Maybe you can throw some light.
A great question. So I've actually spoken about DeepSeek 3 times here this week. In a workshop on Monday, and sort of an industry trend session on Tuesday, and then in my keynote earlier today. So interestingly enough, we combine CPU, GPU, and system software to enable DeepSeek-like innovations and value to end users. Specifically, if you look at the DeepSeek white paper that underpinned all of their innovation, where they had to come up with, necessity, the mother of invention, had to come up with resource-efficient optimizations. They published this in August of last year, so it wasn't that recent. Lots of open source disclosures a couple of weeks ago built on that, but the core paper, there's about, 30, 40 researchers cited in that paper. One friend, Lou himself, CEO of High Flyer, is also in that paper. They show early on one of the key trends that WECA is working on. So Moore's Law is doing really well for accelerators, for CPUs, for models. Models are just crazy in terms of their progress along Moore's Law, but memory is not, right? There's a growing gap between the accelerator, processing power, the flops that the models are consuming and delivering value for, and a gap that's growing because high bandwidth memory capacity and bandwidth is not keeping up. Networking is incredibly fast, but it can't be fast enough. It's NVLink is great. It's not keeping up with some of the accelerator accounts. So what WECA is doing is system software combined with open source contributions to create more efficiency out of the existing CPUs and GPUs that are in memory that's already available. So one of the things to think about is we have for a long time in the industry the notion of software-defined storage. That's fundamentally where WECA started in HPC. Now we need to think about the concept of software-defined memory. And it sounds weird to say, but again, it's already in practice. We're seeing the leading foundation model labs, and DeepSeek open source this and disclose it really first in terms of at scale, of combining lower cost flash devices, NVMe devices, SSDs, they go by many names, and combining those into a pool that can deliver memory bandwidth. But when you combine the capacity you get for enabling memory bandwidth, you end up with effectively petabytes of system memory, petabytes of DRAM class, and not HBM. That's very, very high performance and high bandwidth that's not shipped, but on the motherboard, and effectively off the motherboard on the network using the compute network NVLink, as DeepSeek documented you can do. The concept of limitless memory now for our models and efficient pooling of memory so that the DeepSeek class and the next generation of reasoning and post-reasoning models can efficiently generate process input tokens, never process the same input token twice, efficiently generate reasoning tokens. And what we end up charging for in the business of AI, because I joke AI is really just HPC plus unit economics, what we end up charging for, of course, is the output tokens. So the efficient generation of those by only decoding unique output tokens and not wasting precious GPU cycles on the same refill tokens.
Yeah, thank you. Can I request Dr. Sudarshan to give a concluding remark and vote of thanks? And also before that, I request Dr. Sudarshan to hand over the token of a small development to India.
So we also, it is not just a collaboration of what we have, but each of us also innovating. And actually, what Valentin just mentioned, the compute, the interconnect, the memory, if they don't synergize, then we have Bangalore traffic inside the HPC-AI. So those who of maybe we might have to Google a little bit, but I think we are a case study across the globe. It's a very amazing thing. And this kind of innovations, along with the synergy that we develop as various organizations, it's important. Thank you so much. And Dr. Manish very clearly brought out, end of the day is market driven. And the benchmarking he was mentioning, it takes time. You cannot introduce a new benchmark unless it is tested. So the R&D, what we do versus market-driven benchmark, there will always be a delta T. Earlier it used to be 5 to 7 years. Now we are looking at 18 to 36 months. Hopefully one day it will become 6 months or so, which is more palatable. That is what, thank you sir for bringing up some of the aspects, journey of gaming to CUDA to GPU. That's nice to recap, so to say. And Tensor, as I said, keep everything open for innovation. When you actually monetize, you try to take your share. Don't try to curtail the innovation right at the beginning by putting in price tag. That is a very good model when you want to collaborate, because the entry barriers will be minimal for best innovation. So now you see, Parminder talking about things that are not looking seemingly cool, the plastics, the sheet metal, the packaging. These are small things, but in the end, you don't pass the QC for production. So he says, except for the active components that we need to get discrete, all the rest are in place. So we see a rounded ecosystem developing and enabled by the policy changes by BT, Mr. Marina, yes, highlighted. So thank you so much. It was very enriching. So the journey is not about how we collaborate, but also co-innovate. I think that is what is going to take us forward. And this can go beyond boundaries. We don't have to worry about whether it is India or Indonesia. All of us, we are doing it for the humanity, let the society advance, so that nobody gets stuck in the space and we have enough technology to travel two-way without enemies. Thank you so much. It was an amazing session. In the interest of time, we'll conclude. Maybe while I give a thank you memento, during that time, each of you want to have maybe a one-line conclusion or a punchline that people can remember. Up to you.
I like to conclude this. For me personally, and I think everyone that I speak for, we are on a mission to advance AI. That's the most important thing, and certainly all the benefits that AI brings, as well as being conscious of the risks. So we're very, very proud to be part of this, and thank you for inviting us.
Then we get something for that.
Thank you. Thank you so much. Thank you very much.
Today is the festival of color in India. Today is the Holi, so I see the synergy. Holi is fire, we have the fire, and there we forget all the things and try to make new friends and do the collaboration.
Great.
So with that, I would like to make a note that collaboration is the key to make successful. We are open for collaboration. So that's our successful journey. Thank you.
Thank you.
Okay, my closing remark is we innovate, collaborate, and put it into use for humanity and industry. Okay, so ultimately, it has to come on silicon and so on. Thank you.
Parminder-ji or David-ji, you will get it when we come to Delhi.
You missed it.
So
Yes.
Thank you for a great SCA Asia to the organizers for the opportunity for all of us. And thank you, Dr. Misbah, Deepika, Ramesh, and Sridhar for coordinating for all of you attending. And have a nice further stay, enjoy the evening, enjoy the festival of colors, and we catch up again in another stage. Thank you.
Thank you.
Thank you. Thank you, sir.
Thank you.
Yes, sir. Sir, you can log out. Thank you so much. After we will bring it there. Thank you. I think we can log out. Yeah, we can log on. We'll take a group photo here.
I'll put the bags.
Yes, yes. Full screen.
Just 1 minute. But I think we have substance. I think all the participants are going to come.
1, 2, 3. 1, 2, 3.
It's a nice room, but yeah, you get no worries.
I love Risk 5, by the way, because I have a cybersecurity background, so we.
Pen drives on that.
I paused the recording during lunch, and after that I will not start.
Very good.